Hi everyone, today we will be talking about difference of squares. So this is a very important math concept that shows up throughout middle school and high school competition math, and it's very simple, but it will show up in many different ways. So it's important that we first memorize this formula here, and then we can use this formula in different types of questions, and it's important to identify when we can use it. So we see here that a squared minus b squared is equal to a plus b times a minus b. And we call it difference of squares because we're finding the difference between a squared and b squared. So if we want to double check this, we can see the reason this works by multiplying out a plus b times a minus b. So a times a is a squared plus a times b, that's ab, then minus a times b, then minus b times b, so that's minus b squared. So we see that ab and minus ab cancel out, and that gets us a squared minus b squared. So we know that formula works. So first, for a simple problem, you usually won't get it in this form, but it's good to just know things like this. So what is 2024 squared minus 2023 squared? So this is in the same form that we were just looking at. A squared minus b squared is equal to a plus b times a minus b. Except in this equation, or in this question, a is equal to 2024 and b is equal to 2023. So we can just substitute those values in. So 2024 squared minus 2023 squared is equal to 2024 plus 2023 times 2024 minus 2023. So we can just add 2024 and 2023 to get 4,047, and then 2024 minus 2023 is just 1, because those are 1 apart. So 4,047 times 1 is just 4,047, and that's the answer to this problem. So now for a problem that looks a little bit more complicated, we want to find the value of this expression. However, we see on the right here, we have some equations that look like what we were just looking at in the form a minus b times a plus b. And then on the left, we have some differences of squares. So let's start by trying to factor those differences of squares we have. So 100 squared minus 7 squared, that's equal to 100 plus 7 times 100 minus 7. And then we could also factor 70 squared minus 11 squared, and that's equal to 70 plus 11 into 70 minus 11. And there's a reason I'm not simplifying these expressions yet, because now let's just write these factored forms in the same expression we had earlier. There we have 100 plus 7 times 100 minus 7 over 70 plus 11 into 70 minus 11. And then we're multiplying by 70 minus 11. Just going to move this over. Okay. 70 minus 11 into 70 plus 11 divided by 100 minus 7 into 100 plus 7. So we see here that we can actually cancel out a lot of those factors from the numerator and denominator. So we see that 100 plus 7 cancels, 100 minus 7 cancels in the numerator and denominator, 70 minus 11 cancels, and then 70 plus 11 cancels. So since our numerator and denominator were the same, that means that our answer is just 1. So that may have looked a little bit intimidating, but if we break down the different parts of the question, we see that it was actually very approachable. Given 3 consecutive positive integers, what is the positive difference between the square of the middle integer and the product of the first and last integers? So I'm going to show 2 ways to do this problem, but first we'll just do the regular algebraic approach, if you were to just see this and try this out. So let's say that our three consecutive positive integers are n minus 1, n, and n plus 1. So it's asking for the positive difference between the square of the middle integer. So the middle integer is n, so the square of that is n squared. And it's asking for the difference, so we'll be subtracting. And then the product of the first and last integers. Well, the first integer is n minus 1, and the last integer is n plus 1. So that product is n minus 1 times n plus 1. So hopefully that form n minus 1 times n plus 1 seems familiar to you, just like that formula we were talking about in the beginning, a minus b times a plus b. So we know that this actually simplifies to n squared minus 1 because of that difference of squares formula. And then we can carry that n squared down. So we're doing n squared minus the quantity n squared minus 1. So we can just distribute this negative sign, so that gets us n squared minus n squared plus 1. So n squared and minus squared cancel out, and we just get 1. So that's the algebraic way to do this, but we notice that they aren't giving us many restrictions in this problem, and they're not telling us that it has to be a specific set of three consecutive positive integers. So we can just choose our own. So making sure that we choose positive integers, we can say that our three consecutive numbers are 1, 2, and 3. So if we're finding the difference between the square of the middle number, well, the middle number is 2, so 2 squared is 4, and we're subtracting the product of the first and the last. So the first is 1, and then the last is 3. So 1 times 3 is 3, and then 4 minus 3 is 1. So that's a simpler way to do it. And the reason we know this works is that when we looked at our algebraic approach, we never had an n left over once we simplified, which means that this result, this difference, would be independent of whichever numbers you choose. It'll always be 1. What is the product of all integer values of x for which the values of the absolute value of x squared minus 9 is a prime number? So this time they give us the difference between two squares, because we know x squared is a square and 9 is a square, and we're looking for the difference between these two, and we should then factor it. So if x squared minus 9 is equal to x plus 3 times x minus 3, then the absolute value of x squared minus 9 is just the absolute value of x plus 3 times x minus 3. And really, this absolute value, since it only means that we're looking for a positive version of something, and in the end we're looking for a prime number, we really just want x squared minus 9, or in this case, since we factored it into x plus 3 times x minus 3, to either be a prime number or -1 times a prime number. So let's just try plugging in some random value of x so we can see the properties of this. So let's just say we put in x equals 5. So if we put x equals 5, we'd have x plus 3, so that would be 5 plus 3, and then times 5 minus 3. So 5 plus 3 is 8, and 5 minus 3 is 2. However, if we're multiplying 8 times 2, that's a composite number, because we know that in order for a number to be prime, its only factors are 1 and itself. So we see that if both of these factors, x plus 3 and x minus 3, are both not equal to 1 or -1, then there will be two numbers that will multiply to a composite number. Therefore, we want x plus 3 or x minus 3 to be 1 or -1. And then whatever the other value is will be our number. So let's just find the values of x that work for this. So x plus 3 is equal to 1. That would get us x equals -2. Then x minus 3 equals 1. Gets us x equals 4. X plus 3 equals -1. Gets us x equals -4. And then x minus 3 equals -1 gets us x equals 2. So the reason that this works, let's just say we'll take x equals 4 as an example for one of these. If we plug that in, then we have the absolute value of 4 plus 3 times 4 minus 3. And 4 plus 3 is 7, which is a prime number on its own. And then 4 minus 3 is 1, which is what we were looking for with setting all of these equal to 1 or negative 1. So since we have 7, which is a prime number, times 1, that means that we'll get another prime number. And if we plugged in, let's say, negative 4, then we'd have the absolute value of negative 4 plus 3 times negative 4 minus 3. So that's negative 1, and that's negative 7. So we see that's also equal to 7. So if you wanted, you could try that out with all of the solutions to make sure they work, and they will. And we see that the question is asking for the product of all integer values of x. So that means we just have to multiply our solutions together. So negative 2 times 4 times negative 4 times 2, that's just equal to negative 8 times negative 8. And that's equal to 64, which is our final answer. Pick two consecutive positive integers whose sum is less than 100. Square both of those integers and then find the difference of the squares. Which of the following could be the difference? So we're also going to look at this problem algebraically, like that one earlier. Let's say that our two consecutive positive integers are x and x plus 1. So we're given that their sum is less than 100. So that means that x plus 1 is less than 100. So that we can simplify that to 2x plus 1 is less than 100. And we'll leave it there for now. So then the question is telling us to square both of those integers. So x squared is just x squared. And then x plus 1, quantity squared, we'll leave it like that for now. And it wants us to find the difference between these two. So we know x plus 1 is bigger, so we have x plus 1 whole squared minus x squared. And notice that this is the difference between two squares, so we can use that same formula. So if we're having x plus 1 whole squared minus x squared, that's equal to x plus 1 plus x times x plus 1 minus x. So x plus 1 plus x, that's just 2x plus 1. And x plus 1 minus x, well, x and negative x cancel out. So that just gets us 1. And 2x plus 1 times 1 is just 2x plus 1, so we can ignore this factor of 1. So that means that this difference that they were looking for up here is just equal to 2x plus 1. Since 2x is always an even number because 2 times anything makes that number even, and we're adding plus 1, and an even number plus 1 is an odd number, we know that 2x plus 1 will be odd. And since we have many answer choices here, we can just cancel out any of the answer choices that are even, and that only leaves us with 2. So we have either 79 or 131, but we want to remember that first constraint where the sum was less than 100. So we wrote this inequality here where 2x plus 1 is less than 100. And since that difference we're looking for is 2x plus 1, and we know that 2x plus 1 is less than 100, that means that our difference is less than 100. So therefore it could not be 131 because 131 is greater than 100. So that leaves answer choice C, 79. Okay, on to the next problem. So I know we didn't get to this in class, but if you guys are either coming back to this later or want to look ahead, what is the largest power of 2 that is a divisor of 13 to the 4th minus 11 to the 4th? So what's important to note here is that if you have something to the 4th power, that's also technically a square. So 13 to the 4th power is really just 13 squared again. Because remember, when you have this 2 and this 2, they get multiplied together to get 4. So similarly, 11 to the 4th is equal to 11 squared, So that means that 13 to the fourth minus 11 to the fourth is 13 squared whole squared minus 11 squared whole squared. And we know that the a squared minus b squared formula is a plus b times a minus b. So we can just do 13 squared plus 11 squared into 13 squared minus 11 squared. And we can actually just do that process again for this factor here. First, we'll just bring down the 13 squared plus 11 squared. And then for the 13 squared minus 11 squared, that's equal to 13 plus 11 into 13 minus 11. So that makes it a lot easier to simplify this, because if we look at the beginning problem, we don't want to find 13 to the fourth and 11 to the fourth manually and then divide and see how many factors of 2 we get. So we know that 13 plus 11, just by adding, that gets us 24. And then 13 minus 11 is 2. And then for this 13 squared plus 11 squared, we can do it manually. And we were talking about this last time. I don't know if you guys remembered, but it's very important for you to memorize a lot of your squares, especially up to 30 if you are willing to, because it really helps with all sorts of problems. So we know that 13 squared is 169 and 11 squared is 121. So we can add those together. And that gets us 290. And now we can just find the largest power of 2 that divides the multiplication of this. So we know that we have 1, 2 in just the factor 2 itself. Then 24 is 2 times 2 times 2 times 3. So we have 3 powers of 2 there. So we had 1 from here, from the 2, then 3 from the 24, and then we just have to find how many powers of 2 divide 290. So if you did 290 divided by 2, you get 145, and 145 is odd, so you can't have any more factors of 2 in there. So 290 contributes 1, 2. So altogether we have 1 plus 3 plus 1, which is 5 powers of 2. So our answer is 2 to the 5th, which is 32. Okay, on to the next question. If a, b, c, and d are positive integers such that 1 minus 1 divided by 324 is equal to a divided by b times c divided by d, what is the least possible value of a plus c? So this is another time where it's very important to recognize your squares. So if you know your squares, you would know that 324 is equal to 18 squared. So we can write that expression we're given as 1 minus 1 over 18 squared. And that's really just 1 squared over 18 squared. And we know that that means that it's 1 minus 1/18 whole squared. So using that same formula we've been using throughout, we know that a squared minus b squared is a plus b times a minus b. So in this case, 1 minus 1/18 squared is 1 plus 1/18 times 1 minus 1/18. So that's 1 can be rewritten as 18/18. So 18 plus 1 is 19/18. We're multiplying that times 18 minus 1 is 17/18. And we notice that this minimizes our value of a and c, which is what we're actually looking for in the problem. Because if you multiplied it out, our other possibilities would be 323 over 18 times 1 over 18, or something like that. And we know that that would make a and c, their sum, larger. So by having a and c closer together with 17 and 19, we know that minimizes their sum. So if we're looking for the least possible value of A and C, that's just 17 plus 19. And it doesn't really matter the order. So if you add that together, you get 36, which is your final answer. Okay, so this is just a common problem that we've seen throughout. So we just made this on our own, but it is similar to some ideas you'll see on the AMCs. And it's the idea of having to use knowledge of difference of squares, but it's not given directly to you in the problem. So we see here, if we have 1 plus 2 to the first times 1 plus 2 squared times 1 plus 2 to the fourth, and so on, times 1 plus 2 to the 32nd, and that's equal to 2 to the n minus 1. And we're looking for the value of n. So it might be a little bit tricky to see where to start, but notice that if we multiply by 2 minus 1 in the numerator and denominator, and I'm just going to copy all of those values up here. Well, now we have 2 minus 1 times 2 plus 1. So again, that's a plus b times a minus b. So that means that 2 minus 1 times 2 plus 1, that's really just equal to 2 squared minus 1 squared, and 1 squared is just 1. So that was our first step of simplifying some terms, but notice that we can actually continue this pattern. Now we have 2 squared minus 1 times 2 squared plus 1. So again, that would be equal to 2 to the fourth minus 1 for these two terms. That means we can just cancel those out and replace them with 2 to the fourth minus 1. And now notice once again, we have 2 to the fourth minus 1 times 2 to the fourth plus 1. So that simplifies to 2 to the 8th minus 1. So we can then, again, erase these terms and replace them with 2 to the 8th minus 1. And do you see like this pattern that we're forming here, where whenever we multiply those two expressions together, they give us another term that we can then use to continue this chain reaction. So now we have 2 to the 8th minus 1 times 2 to the 8th plus 1, and that's equal to 2 to the 16th minus 1. So we can replace those terms with 2 to the 16th minus 1, and then 2 to the 16th minus 1 times 2 to the 16th plus 1 is 2 to the 32nd minus 1. And then finally, these are our last two terms in the numerator. 2 to the 32nd minus 1 times 2 to the 32nd plus 1. That's just equal to 2 to the 64th minus 1. But notice in that denominator, we still have 2 minus 1 from when we multiplied by 2 minus 1 in the numerator and denominator. But you guys have probably already noticed that 2 minus 1 is just equal to 1. So if our denominator is just 1, then any number divided by 1 is just itself. So we can ignore that 1, and that just leaves us with the numerator, 2 to the 64th minus 1. So remember that we were given that that expression was in the form 2 to the n minus 1. So if 2 to the 64th minus 1 is equal to 2 to the n minus 1, then our value of n that we're looking for is just 64. And that's our final answer. Okay, so for the next question, we are trying to look for the value of this expression. So we see that difference of squares again, and we want to make sure that we can factor this. So first, let's just use difference of squares. So we have 3 to the 2008 squared minus 3 to the 2006 squared in the numerator. So first, let's factor that. That's just 3 to the 2008 plus 3 to the 2006 times 3 to the 2008 minus 3 to the 2006. And we can do a similar thing in the denominator. If we have 3 to the 2007 squared minus 3 to the 2005 squared, we can just have 3 to the 2007 plus 3 to the 2005 times 3 to the 2007 minus 3 to the 2005. And now we see that we've simplified it into these terms that are easier to cancel out, but we can also then factor some powers of 3 out of these terms. So first, let's look at this term here, 3 to the 2008 plus 3 to the 2006. We can actually factor a 3 to the 2006 out of this term. So 3 to the 2008 divided by 3 to the 2006 is just 3 squared. That's plus 1. And then we can also we can factor out a 3 to the 2006 in the term on the right. So we have 3 to the 2006 times 3 squared minus 1 for our numerator. And we can do a similar thing with the denominator. So we can factor out 3 to the 2005 in the denominator because 3 to the 2005 is the greatest common factor between 3 to the 2007 and 3 to the 2005. So if we take out the 3 to the 2005 from that expression, we're left with 3 squared plus 1. And then if we do the same with the term on the right in the denominator, we have 3 to the 2005 times 3 squared minus 1. So we notice that because we're multiplying these terms, that some of the terms actually cancel in the numerator and denominator once again, so that's something we always want to look for. So the 3 squared plus 1 cancels in the numerator and the denominator, and the 3 squared minus 1 cancels in the numerator and the denominator. And then we see that the powers of 3 that we have left over are close to canceling out completely, but we still have a little bit more in the numerator. So if we have 3 to the 2006 in the numerator and 3 to the 2005 in the denominator, we know that we can solve that by subtracting the exponent. So 2006 minus 2005 is 1. So that means that this part here simplifies to 3 to the first. So we can cancel that out and say that that part leads to 3 to the first, and then we don't want to forget about that same thing here. So 3 to the 2006 divided by 3 to the 2005, that's also equal to 3 to the first. And 3 times 3 is 9. So that's our final answer. So as you see, we covered a lot of different types of problems with difference of squares, and it'll show up throughout middle and high school competition math. And it's just present everywhere, so you always want to look for it. And you notice that we went across similar topics such as factoring and canceling out terms in the numerator and the denominator, but this idea can actually show up in any type of problem. So whenever you're using factoring or you can't think of the next step, just try to see really quickly if you have anything in the form of a plus b times a minus b or a squared minus b squared, and that might help you simplify your problem. Thank you for watching.